Hello everyone. So from today I'm going to start with my lecture on function of several variables. The main objective of this lecture is to understand limits, continuity and differentiability of function of more than one variable. Basically we'll be taking into consideration only two variables and sometimes three variables. So before starting with limits, we need to understand some definitions. The first definition that we need to understand is open ball. So let us define. Let A, where A is any point in Rn, and let delta be a positive real number. So delta is any real number. Then the set of all points x belonging to Rn such that the distance between, like if this is a point, if this is a point, then the set of all those points which are in the delta neighborhood of A is the collection of these x's is known as open set, where this is norm as we know in vector space. Okay, now so we normally take it for R2. So let A is equals to some AB, a point in R2. Then as we can say, an open ball can be defined by all those points which is in the ball of delta neighborhood of A. And basically when we use the norm definition, norm x minus A less than delta, then where A is this and x is any xy in tuple, so we have norm definition is x minus A whole square plus y minus b whole square less than delta square. And basically this is this point, x minus A whole square plus y minus b whole square is equals to delta square is a circle. So we see that an open ball with delta neighborhood is a circle basically, and that is known as open ball. Now we can even represent R2 in the form of rectangular neighborhood. So we can represent R2 in form of rectangular neighborhood, where we take x in between A and B, any 2 points in the x-axis, and we take C and D, any 2 points in y-axis, and we take these points. So this is known as rectangular neighborhood. Similarly we can have for R3, R4 and others. Okay, now we start with limits. A function f of two independent variables x and y is said to tend to a limit a as the point xy tends to a given point ab if to each epsilon greater than 0 there exists a delta greater than 0 such that function of xy minus a is less than epsilon for all the points xy of the domain which belongs to the same deleted delta neighborhood n dash of AB. So basically, what is a function? A function is a mapping from one point to from a domain to codomain. So what is the definition of limit is if there is a sequence of points, obviously here it is two dimension xy, and it is going towards some AB. This sequence is converging towards some AB, and at the same time, if the function f of xy is converging towards some point A, then here if we have a delta neighborhood of AB here, then in the epsilon neighborhood of AB, f of xy of A, f of xy will be there if xy is in the delta neighborhood of AB. And we denote this thing by limit x tends to A, y tends to B, f of xy is equals to A, or limit xy tends to AB, f of xy is equals to A. So now let's do some examples. So now the question is, let f of xy is equals to x square y square divided by x square plus y square. Using delta definition, epsilon delta definition, establish limit x tends to 0, y tends to 0, x square plus y square is equals to 0. So according to definition, what we need to assume first let epsilon greater than 0, and for this we need to find a delta greater than 0 such that what should happen if this is the limit. So 0 is the limit and the function is x square y square. So what we need is f of xy minus limit, which is 0, is less than epsilon whenever delta neighborhood, that is x square, x minus 0 whole square plus y minus 0 whole square is less than delta square. So now f of xy minus 0 is x square y square divided by x square plus y square minus 0. We can rewrite this as modulus of x square y square divided by x square plus y square, and we see x square is always less than x square or equal to x square, and if we add another positive quantity it will be the same thing, and again y square will be less than equal to x square plus y square. Same argument, because all these are positive quantities of real number. So what we can do is this is less than equal to modulus x square modulus y square divided by x square plus y square, since x square plus y square is a positive quantity, and this is less than equal to x square plus y square into x square plus y square, and this is divided by x square plus y square. Since x square plus y square is a positive quantity, so this and this will cancel, and this is equal to x square plus y square, which is less than epsilon whenever delta is equal to epsilon, delta square is equals to epsilon. See, x square plus y square is less than delta square, x square plus y square is less than delta square, that is delta is equals to root over epsilon. So hence what we get is we find epsilon, a delta for this epsilon for which the epsilon delta definition is correct. Hence limit x tends to 0, y tends to 0, f of xy is equals to 0. Similarly, we move on to the next example. In this case, establish the limit this. So in this case again, let epsilon greater than 0 be given. To find a delta neighborhood of 0 0 0 0 such that in that neighborhood n all xy such that this minus 0 is less than epsilon, that is this, but this can be rewritten as this. Clearly this is less than this, previously we had done, and this is less than this, and this thing will always be less than 1 because x square plus y square is always greater than x square minus y square modulus. So what we can write is x square y square, x square minus y square, x square plus y square minus 0 is equal to modulus of this, which is less than x square plus y square root over into x square plus y square root over into 1, which is equals to x square plus y square less than epsilon. That is, this is less than x square plus y square, x square minus y square divided by x square plus y square minus 0 is less than epsilon if 0 less than x square plus y square less than delta square, that is delta is equals to root over epsilon. Thus the requirement is satisfied and hence the limit is established. So this is how we find the limit. So now we understand that non-existence of limit. So we have an example for this to prove the non-existence of limit. So we need to prove that limit x tends to 0, y tends to 0, xy divided by x square plus y square does not exist. So let us take the function xy divided by x square plus y square. So we need to show that this does not exist. So we have a simple method. What we do is we approach y-axis by y is equals to mx. So we get limit y tends to 0 is equals to limit when y tends to 0 or x tends to 0, we have y tends to 0. Hence we get limit x tends to 0, y tends to 0, xy divided by x square plus y square is equals to limit x tends to 0, x dot, in place of y we write mx, which is mx divided by x square plus m square x square. That is limit x tends to 0, x square dot m divided by x square common 1 plus m square, x square will cancel, and this is m by 1 plus m square. Now as m is arbitrary, so we get the value of limit for m is equals to 1 as 1 by 1 plus 1, which is half. But for m is equals to 2, we get 2 by 3. So hence we get two limits or more than one limit for the same value of functions. Hence the limit does not exist. So put y is equals to mx, then we have this thing. Again we see that f has different constant values on different lines through the origin, hence the limit does not exist. We have another method to show this, and that is the polar coordinate method. So let us discuss that. So here what we do is we take the polar coordinate system. So x will be denoted by r cos theta and y will be denoted by rho sin theta. So then f of xy will be x square plus y square, which is rho cos theta dot rho sin theta divided by rho square, as sin square theta plus cos square theta is 1. So this is half sin 2 theta. This and this will cancel. So we get this. Now what we have is, when x tends to 0, y tends to 0, then we have only one condition, rho tends to 0, but theta has no conditions. Hence, for different values of theta, we'll get different values for the limit. From the above, we can see that for different values of theta specified arbitrarily, we get different values for limit. Hence, the limit does not exist. For the existence of limit, we need to have epsilon delta definition. See, note, the above method can only say if a limit does not exist. It cannot say cannot be for the proof for the existence of limit. So we do one more example for the better understanding of this. So let f of xy is equals to x square y divided by x to the power 4 plus y square. So we need to look for the existence. So here what we see is, when we take putting y is equals to mx, then what we get is f of x mx is equals to x square dot mx divided by x to the power 4 plus y m square x square, which is equals to x cube m by x square plus m square, which here limit x tends to 0, x m divided by x square plus m square will be 0. Now y, if we take y is equals to mx square, the parabolic path, then let's see what happens. So f of x mx square will be x square dot mx square divided by x to the power 4 plus m square x to the power 4, which is equals to x to the power 4 m by x to the power 4 1 plus m square. Here these two cancels, and the limit x tends to 0, m 1 plus m square will be m 1 plus m square. Here m is arbitrary, and hence this can not always be 0. For m is equals to 1, this is different. Hence we conclude that there are more than one limit for this function. Hence the limit does not exist. So now we start with repeated limit or iterated limit. Previously what we did was double limit. So now we start with repeated limit. So let us define it. So definition: let f of xy be defined in a certain neighborhood of AB. Then limit x tends to a f of xy, y remaining constant, when exist, will be different for different values of y, and in fact this limit will be a function of y, say phi of y. If then limit y tends to be phi of y exists and is equal to L1, then we write limit y tends to be limit x tends to a f of xy is equals to L1. L1 is then called the repeated or iterated limit. So what is it basically saying is, if we have a function f of xy, so here what we do is, we first find the limit at x tends to a and keeping y constant, letting y to be constant. Then what we get is some function of y. Again, if we find the limit as y tends to be for this function and we get some L1, then L1 is said to be repeated limit and is denoted by, obviously, phi of y is limit x tends to a f of xy, which is L1. So this is known as repeated limit. So now let us check how to find repeated limit. So we do with one example. So let f of xy is equals to x plus y, x minus y. So for this, what we do is we first find the repeated limit. Y tends to be limit x tends to a x plus y, x minus y, which is, so first we do with x, taking y as common, y as constant. So we do limit y tends to b, and for this limit x tends to, we need to find at 0. So x tends to 0, y tends to 0. So limit x tends to 0 will be, we just put the value. So this is 0 plus y and 0 minus y. So this is limit y tend to 0, 1 by minus 1. Y and y will cancel, which is minus 1. And hence we get limit y tends to 0, minus 1 is equals to minus 1. Similarly, we can go for the other part. Limit x tends to 0, limit y tends to 0, x plus y, x minus y is equals to limit x tends to 0, and again we put the values and we get x plus 0, x minus 0, which is limit x tends to 0, which is 1, and hence the limit is 1. So what we see is we get the, both the repeated limit exists in this case, and but they are different. One is minus 1 and other is 1. Now we check for the double limit. So for the double limit, what we do is limit x tends to 0, y tends to 0, x plus y, x minus y. So here we can clearly see that this is, if we put y is equals to mx, so what we get, limit x tends to 0, x plus mx divided by x minus mx, which is limit x tends to 0, 1 plus m, x common, 1 minus m, and this will cancel, and it is 1 plus m, 1 minus m, which is different for different values of m, hence the double limit does not exist. So what we see here is the function, both the repeated limit exist, they are different, but the double limit does not exist. So even when both the repeated limit exist and have the same value, this is for different values. So now we check for the next case. So let us verify for this function. So here x square y square f of xy will be x square y square divided by x square y square plus x minus y whole square. So first we check for the repeated limits. So limit x tends to 0, both are going to 0, and limit y tends to 0, x square y square divided by x square y square plus x minus y whole square. So what happens is limit x tends to 0. When we put y is equals to 0, so this part is 0, this is 0, and here is 0. 1 we have x, so this is non-zero, hence we get 0, which is 0. And again limit y tends to 0, limit x tends to 0, x square y square divided by x square y square plus x minus y whole square is equals to limit y tends to 0. Similarly, what we get is 0, and this is 0. So here both the repeated limit exist and both are 0. Now we go for the double limit. So let's see. For the double limit, what we do is we approach from y is equals to x plane. So what we get is f of x comma x is equals to x to the power 4 plus 0, which is 1. Whereas for x is equals to 0 or y is equals to 0, when we have f of 0 comma y is equals to 0, and limit this is 1 along this, and limit this is 0 along x is equals to 0 plane. So hence the double limit does not exist, as it has more than one value of the limit. So from this what we understand is, even if both the repeated limit exist and they are same, it might happen that the double limit might not exist. So we have one example which is a homework, so try it. So we do the last example for our repeated limit or limit, and we'll start with continuity for in the next class. So here what we have is, we have a function f of xy which is equals to x sine 1 by y plus y sine 1 by x when xy not equal to 0, and 0 when xy is equals to 0. Okay, so we recall something from real analysis, and that is limit x tends to 0 sine 1 by x does not exist. This is important, so we recall it from real analysis. That might be, you might have a knowledge of it or just take it for granted. So now what we have, limit x tends to 0 f of xy, what will happen is limit x tends to 0 x sine 1 by y plus y sine 1 by x. But as limit algebra of limit, we can just take limit inside, and what we get is limit x tends to 0 x sine 1 by y plus y limit x tends to 0 sine 1 by x. This part does not exist, and hence this whole limit does not exist, and hence if we put limit y tends to 0, this limit will also not exist, hence the repeated limit does not exist. Similar for the other part, limit y tends to 0, this limit will not exist. So both the repeated limit does not exist in this example. Now we check for the double limits. So for the double limit, we saw that this is an example that shows that the double limit exists, but both the repeated limit does not exist. So for this what we check is, we check with epsilon delta definition, sine 1 by y plus y sine 1 by x. Here the limit, we assume that the limit goes to 0, so minus 0. So this is equal to x sine 1 by y plus y sine 1 by x. Okay, and this is less than equal to triangle inequality 1 by y plus y sine 1 by x, and this is again less than equal to modulus of x sine 1 by y plus modulus of y sine 1 by x. But sine of any value is less than 1. Sine function it is, so highest value is plus 1 or minus 1, so its modulus is always less than 1. So what we have is less than equal to modulus of x, here we will have equal to plus modulus of y, since sine of any function is less than 1. Now what we had done is, this is less than something, that is x square plus y square plus x square plus y square. So what we get is 2 root over x square plus y square, and if we choose an appropriate one, that is if we choose epsilon by 2 is less than x square plus y square, this is less than epsilon, then we'll have epsilon by 2 is less than x square plus y square, and this is square. So if we choose delta is equals to, so, and this will be delta square, so if we choose delta is equals to epsilon by 2, hence our epsilon delta definition will be met, and limit x tends to 0, y tends to 0, f of xy is equals to 0. We'll establish this thing. Thank you for watching my first lecture. Sorry if the sounds or any images are wrong. Follow the link in the description where you will find a group, WhatsApp group, where you will find the notes of this lectures. Thank you.